After this Android architecture, we have one more topic, that was our Android application architecture, right? So we have different things which were involved in a particular application. Like if I go with all the applications, for simply open my Firefox, we have four major components in every application. First one was your user interface. This particular screen was known as activity. All the particular screens were known as activity. Like this one is the activity for your main home page, right? If I open this tabs here, this one is a second activity here. So this user interface is known as the activities in all your application. Like you can go with any application out there. Just simply open a dialer here. Just open a dialer. The dialer also have multiple activities. Like first one is this. So you got some recent calls out there. Then we have activity for our contacts. Then we have activity for our like add contact part. Then we have our activity for our dialer part where we dial our calls. We have different activities in a particular application, right? That was the first major component for the application. Second major component was just services. All the background running processes, like you are playing some music, you are downloading some files, you are uploading some data, whatever background processes you have, all the background processes for the specific application only, for the specific application only. The application background processes were known as your services, right? The background process for your device, the background process for your Android device, they were known as daemons, right? The background process for your device, for your simple main operating system, they were known as daemons. And the background process for your applications, they were known as services, right? After activities and services, we have the broadcast receivers. Like if I simply go with one thing, let's say, whenever your device boots up, whenever your device boots up, your device will simply broadcast a message, but only inside this specific device, right? Your broadcast receiver class was generally used to broadcast some messages to some application, or just to receive some messages, just to receive some broadcasted messages, right? We use the broadcast receiver class to receive the broadcasted message or to broadcast a specific message. Let's say, like if I just go with the file gallery here, right? Okay, I don't have an image. Let's just create an image here. Let's go with the camera. This is my camera here. When you click on the camera, we got some permissions here. I will explain the permissions again. This was the main user interface for the main activity for your camera. This is again an activity, right? I'll create a snake. I'll simply click a picture here. Let's create one more. All right. So when I simply open a gallery, right, and let's say I have two images in my camera device, in a simple camera folder, right? Let's say I want to share this picture. When I click on this share button, my simple device, my device will simply broadcast a message to all the applications. My device will simply broadcast a message in the device itself, right, which will be received by all the applications. That message specifically contain like, can you share the data? Can you share the data? Right? And if they accept that message, or if they have a receiver in their program, if they have a receiver in their program, they will simply receive that message and they will simply reply back to me that yes, I can share the data, and that application will be listed here. That application will be listed here. If I simply install WhatsApp here, after installing WhatsApp, when my system broadcasts the message like, can you share the data? My WhatsApp will receive that message. Yes, I can share the data, and reply back to me that yes, I can share the data, and that application will also be listed here for sharing part, right? So broadcast receivers were generally used to broadcast some messages, broadcast some activities as well. Like let's say you want to perform some actions. When you want to perform some actions on an Android device, we generally broadcast the message, but specifically for the actions, right? Those messages were known as intents. Those messages were known as intent. Let's say that you can compare it with a simple example. Like you have downloaded a PDF file, right? And when you click on that PDF file, you will got a list of applications that can run that specific PDF file, that can open that PDF file. Like you got some Google Drive, you got some MS Office part, you got some like WPS Office. These multiple applications can open your PDF file, right? Means multiple applications we have here which can open a PDF file. That was the intent. Like my Android device will simply broadcast a message. Like, can you open a PDF file? And if any application can open a PDF file, that application will be listed here. But that application needs to reply back to my device. Only then that application will be listed. If my application will reply back to my device that okay, I can open a PDF file, only then that application will be listed on the specific menu at the bottom for our file opening part, right? But again, this was the main purpose for your broadcast receiver, which was used to broadcast the messages in your Android device itself, right? But your broadcast receiver only work for internal net, for the internal Android device only. Cannot work for outside the Android device. Cannot work for the network only. And it cannot work for the network. It will only work inside your device only, right? After this broadcast receiver, we have our content provider. The main use for content provider is the data sharing. Let's say, like, this images were shared, this images were stored. Okay, Ashwin, can you just share your screen if it's possible? So we can just resolve this problem, resolve this error.
Okay, sir.
I just share your screen and let's see. Exploitable Linux 2.0, but that's a different error, not related to mobile part. If you have any problem in the mobile, then you can ask me.
Sir, this is error, sir.
Like, have you tried the Google for this error?
Sir?
Have you searched on the Google for this specific error? Like, why
No,
you are
sir.
getting this error? I'm taking the screenshot and okay. I'll share you the answer, like how you can resolve this part. I need to figure out like why we got this error. But
Okay,
don't
sir.
worry,
Okay, sir.
I'll share the answers.
Okay, sir. Thank
You
you.
can resolve this part. All right. That's why I don't use virtual box. So the main part for the content provider is the data sharing. All the data which was shared between different applications. The data sharing part was performed, was handled, was managed by your content provider. Right? Let's say you have some data, like these images were stored in my file manager, right? These images were stored in my file manager here. I go with the DCIM folder. You can go back, go with the DCIM camera. These image files were stored here, right? Like when you access the data, which was owned by some different application, like this data was owned by my particular file manager. Right? File manager is the actual owner for that data, but that data is also shared with my gallery. Let's say if your contacts were shared by your WhatsApp, if your contact was shared by your Facebook, Facebook can access the contact, your WhatsApp can access the contacts, but that contacts were actually stored by your contact manager. Simple, right? That data sharing part was managed by your content provider. Simple. These are the four major components for all your Android applications. First one was your activity, second one was your services, third one was your broadcast receiver, fourth one was your content provider. The activities were used for the graphical user interface, the GUI version, the GUI content you got on your screen. That was the activity, and all the activities were created by the views. Like if I just go with the any application here, like this is my activity here. This is one of my activity here. This is the because this is a GUI here. Right? This activity consists of multiple views. Like this one is a view. This one is a view. The elements for the activity were known as the view. VIEW. The elements for the activity were known as views here. Right? If I open Firefox, this was the elements. Like this was the view part. This is again a view. This is again a view. The elements, this particular box here is a view. This particular box for private window is again a view. Right? So all your activities consist of different view elements. Right? But we call them view elements. So we can also call them view as well. Second thing was your services. All the background running processes are known as your services. Then we have broadcast receiver, which was used to broadcast the messages in your Android device, right? Or just to receive some message, just to receive the broadcasting message, we also use the same broadcast receiver class. They were just classes in your Java. They were just your Java classes, right? And then the fourth one, we have our content provider, which was again used to manage the shared data or to share the data between different applications. We use our content provider. After this part, now let's move toward our Android device boot process, how your Android device boot up, right? So if I go with Android device boot up, everything starts from the somewhere. Like when you simple press the power button on your Android device, right? Your simple hardware will trigger a particular logic which will execute the function in your ROM memory. Your hardware will trigger a function which was stored in your ROM memory, and your ROM memory stores your firmware. Right? That firmware will simply load your bootloader. That firmware will simply load your bootloader in your RAM. That bootloader was used to load your kernel, and your kernel will simply start a process. We call it init process that was used to initiate different other processes. This is the parent process for all other different processes. If I just go with my application here, this was my application I'm running right now. Let's go with the virtual machine as well. Let's go with the mobile slur. Yeah, I'm running my virtual machine here. I'm clicking on the left hand side. Let's go with our Android virtual device on the right hand side. I go with the processes. I go with different process for the same Android device, not this one. Yes, right here. All right. Let's go with the password as root. And if I connect these devices, for connectivity, we generally use a particular process. We generally take help from a particular process that was again started by the init process. That was your ADBD. We call it Android Debug Bridge daemon. We call it Android Debug Bridge daemon because it's a background running process on your Android device, right? To maintain or to like just to use our Android device, just to control our Android device with the help of CLI, so just to pass some commands to our Android device. We generally take help from this Android debug bridge, right? And this was just a background running process for your particular Android device, right? So for the connectivity part, we need to figure out the IP address for this particular device, and the IP address you can identify in the settings. So if you are using a version lower than 7, then you need to go back to the about phone part in the settings at the last, and then go back to your settings. Go back to your status here. In the status, you will go to your IP address as 192.168.1.7. So you need to use the option like ADB connect. We generally use the command connect to connect with our Android device here. You can also connect with your hardware device as well, or you can also connect with your virtual device as well. But for the hardware device, you need to enable the wireless debugging. Only then you can connect both your computer system and your Android hardware device on the wireless network. Otherwise, you need to use a USB cable. Right? Only then you can use the ADB connect. But on the wireless network, you need to enable the wireless debugging. Otherwise, you will not be able to connect your hardware device. Right? So if I going with this, if I simply go with this virtual device here, this was the IP address as 192.168.1.7. Your Android debug bridge particularly works on a port number that was 5555. Right? ADB have different components. I will explain that part later. But right now, let's go with the boot process again. So I will explain I will explain the ADB just after a few seconds, just after explaining this part. Just after explaining this boot process, I will explain the ADB. Right. So now my device is connected to my particular machine here. So I can just get access to the device, so I can get access to the shell for my Android device. For that part, just go with the command adb shell, and you can process and you can list out the process here with the ps command. You can list out the process here with the ps command, because in general in Linux we use the ps command to list out all the processes there. When you press enter, this will give you a list of all the processes which were in the running state for my particular Android device. And if you go back to the top, you can see we have a process at the top with the process ID as one. This was the first process for your user space, right? This was the first process for your user space, right? That was the init. This init process was used to start all other different things, all other different virtual machine, all other different like your managers and other different things. If I go with the hardware again, your init process will start up all your virtual machines. Your init process will also start all these managers and also works with your applications as well, right? Your init is the first parent process for your all the application and your virtual machines, right? So your kernel will simply start that init process, and your init process will simply, after performing different action, like we have some configuration file which was stored in this init.rc. If I simply go and list out all the permissions out there, just to my machine, if I simply list out all the files here, if I go with ls-l to list out all the files and with proper permissions, I got a list of all the files here. This particular file init.rc, this particular file consists of all your configuration for your specifically init process. When your kernel will start the init process, right? The init process will first execute all the commands which were listed in it in this init.rc file. If you want to see the content, you can go with the cat command init.rc. This file contains some different like commands, you can say. It will be executed by my init process, right? So all the configuration, all the parts, for like your simple file structure, for your like daemons, all different services and all the different actions were specified in this particular configuration file. This in this particular init.rc file. This is the main configuration file for your Android device, for your main user space, right? So your first your init process will execute all the commands which were listed in this particular init.rc file. And again, that init.rc file contained one more important part, that was your debugging. That was your debugger, ADB. Daemon we call it, Android Debug Bridge daemon, because it's a background running process. We call it Android Debug Bridge. It starts with the boot up and it ends with the boot out. Simple, right? So after executing all the commands from my init.rc file, then your init will simply starts a process we call it zygote. This zygote process was used to start all your virtual machine, or you can say all the actions which will be performed by your virtual machine, specifically for your virtual machine. That actions, that operations will be managed by your zygote process. Right, your zygote process will manage all the actions, all the operations for your virtual machine. Let's say I'm right now using this Firefox here. Right? Like I'm using the settings, I'm using Firefox, I'm using File Manager, I'm using Gallery, Camera, Phone, and DY as well. Right? So all different actions, all different applications were managed by my zygote process. Different virtual machines were managed by my zygote process. Right? Again, zygote is just a child process for your init process. Init is the parent process for all other different daemons and services and different processes. Right? Init is the first process for your user space. After this part, your zygote is also responsible for a child process that was your system server. Your zygote will simply start a child process that was your system server, and your system server was responsible for managing all your managers. Right? Your init process will simply initiate another process that handle all your virtual machine operations. Right? That specific process is known as zygote process, which handles all the operations for your virtual machine. Right? That zygote process will again initiate one more child process. We call it surface manager, which again manage all different managers here for different actions. All these managers were initiated, were started, were configured by your server management, by your system server. That was again just a child process for your zygote. If I just go with simple hierarchy here, I'm going with paint. So let's go with the paint here. So at the top, what we have is the init process that again initiate different thing like simple. One of the major component was your init.rc file, because this file contains different commands, and all those commands, all those operations will be performed by your init process. After performing all these operations in the init.rc file, then your init process will move toward your daemons. Right? And one of the most common daemon was your ADB, that again stands for Android Debug Bridge, and we call it Android Debug Bridge daemon, ADB. Simple. After initiating all these things, the init will also initiate one more child process. We call it zygote. Right? That zygote process was used to manage all your virtual machines. Right? Manage all VM operations. The zygote process will manage all your virtual machine operations. Right? With that part, it also initiate a child process that was your surface system server. Sorry, it was your system servers. Right? And that specific system servers were used to manage, were used to start the different managers, like simple activity manager was there, location manager was there, resource manager was there, simple notification manager was there. Different managers were started, were configured, were managed by your system server process. Right? Manage different managers. Simple. This was the main structure for your Android boot process. Right? It again starts with your power button. When you hold that power button, your device will simply send a signal to your ROM. Your ROM will simply execute a function, execute a hardwired function. That was your firmware boot process. That was your firmware. Simple. Your your ROM will simply initiate a function which was stored in your firmware. Right? Your firmware will simply load your bootloader in your memory, in your primary memory. We call it ROM. We call it RAM again, random access memory. Right? Your firmware will simply load your bootloader, so again stored in your secondary storage, like simple your simple internal storage, like simple SD card and the other different storage, but not in your main primary memory like simple ROM and RAM. Your bootloader was stored in a secondary memory. Like this can be stored on different folders. One of the most common folder for this kind of bootloader was your recovery. Right? This can also be stored on like system folder. But again, your firmware will simply load that bootloader in your memory. Right? After this bootloader will again initiate a process. You can say your bootloader will simply start your kernel. And all your kernel was again stored in the system directory again. Your kernel will simply start a major process that was your init process. Right? Your kernel also perform different operations like simple hardware management, simple hardware checks, and all different things are also performed by your kernel, like simple it will initiate input output, it will start different drivers, and all of the different operations are also performed by your kernel. Right? But again, the major function for the kernel after performing all the common parts for the kernel will simply start init process for your user space. Right? Then your init process will again perform different actions, and one of the most common action was specified in this specific init.rc file. This consists of different commands. So your init process will execute all the commands specified in this init.rc file and then start all your daemons. And one of the most common daemon is your ADB, Android Debug Bridge daemon. Right? And again, after starting all your daemons, your init process will start a child process that was your zygote. The zygote was used to manage all the operation for your virtual machine. Right? So after starting the simple virtual machine for your simple softwares, you will again start another child process that was your system server. The system server process was used to manage all your different managers there. Like all these different managers were managed by your system service process, right? After starting all your managers, then your system, your Android device will simply broadcast a message in the internal. Then your system will simply broadcast a message that the boot has been successfully completed. Action boot completed. This was the message which was broadcasted in the device itself, inside the device ROM. Right? This was the broadcasted message. Again, that was broadcasted by the broadcast receiver class, right? And all the application which receive this application, which receive this message, will simply send back reply to the device. Simple. But again, your system will broadcast the specific message that was action boot completed. It means your boot has been completed. Now you can start your processing part. Now you can execute different application, right? So this was your main boot process. After this, if I go with common files out there, like the major component, the major files in Android application was there. If I go back, my mobile club, let me just start Android Studio so I can show you the files here. All the application, consists of these three major files. First one was your Java or Kotlin program. Second one was your resources, and third one was your manifest file. Right? Manifest file consists of all your configuration, like simple minimum SDK part, the simple permissions, all the different things were specified, were simple stored in this particular Android manifest file. Not this one. Let me open a different project. Like so, this is again the simple process, simple application. Like if you want, you can test it on your Genymotion as well if you want to test, right? But this is a simple application. This is simple Android application, right? All the configuration for a specific application, like what permissions we want for the minimum SDK version, what broadcast receivers we were using, what services we were using, what activities we were using, all this kind of common uh, configuration was stored inside this manifest folder. It consists of a simple XML file. We call it Android manifest.xml. This consists of your configurations, right? Now, after this manifest, after this configuration file, we have our Java. This particular folder, this particular Java folder contains your Java program. Like I have different activities, select one of them was main activity. All your application must contain this activity, right? So all the Java program, all the Java or Kotlin code will be stored in this particular Java folder, right? All the program, all the Java code or Kotlin code will also be stored in this particular Java folder, right? After this Java program, we have one more folder. We call it resources, RES. This folder consists of different XML files. Like simple, it also consists of your media files as well, like your simple icons, your simple media files, your image files you are using, the PDF files if your application contains different kind of media files, different kind of resources, and different kind of resources were also stored in this RES resources folder. But again, it also consists of different XML files like your simple background color, the simple layout for different screen size, and your simple icons and other different things were also stored in this resources folder. If I go with simple external image files, which were displayed here, this particular image file was stored in my drawable folder. And this was the image file index.png that will be displayed in this particular image box here, right? If I go with the layout, layout will simply store the structure for the screen, like simple what was the screen resolution, how this content will be displayed, right? This layout folder will simply consist of an XML file for my screen layout. After this layout folder, we have the MIP map folder. The MIP map folder will generally store some values like your icon. What would be the background icon? What would be the round icon? What would be the square icon? What would be the icon for your square but rounded corners, right? Different kind of icons were stored, were managed by this MIP map folder, right? After MIP map folder, we have our value folder, which again consists of different colors, different string values you have defined in your program code, different themes you have in your particular application, right? These themes, strings, contents, these themes, strings, constants or integer part, and other different coloring part were also stored in this particular theme folder here, or in the value folder here, right? So all your application consists of these four, not four, these three major folders. First one was your manifest, that was your simple configuration file. Second one was your Java folder that consists of your Java functions, Java programs. Third one was your resources, which again consist of different layouts and the colors and backgrounds and icons and image file and other different options, other different additional data we have, right? So all your resources will be stored in this resource folder. All your program will be stored in your Java folder, and all your configuration file will be stored in this manifest folder, right? If I simply execute this file, if I simply execute this one, let me connect my device again, like execute the same command, adb connect, and it's connected. Now we can just test our application on our Samsung Galaxy S7, right? So let's take it on the left hand side, and now let's execute this. This will simply build the application and then send it to my device and install it and execute the specific main activity, right? If everything works fine. Installing the application, launch activity, and here we go, right? This particular image file was stored in this resource folder, in this resource drawable folder. This is the index.png file, right? And this was my activity. You can verify this thing. Like if I just go back to this resource folder, you can go to the layout, and inside this layout folder, we have the activity main.xml, and you can view this thing here. So the main activity, right? All your layout part, all your main activities will be stored here, and so with some configuration part. If you want to analyze the configuration for this particular activity, you can also analyze the configuration. Just go here for the split. Then you can also analyze the XML file with the proper screen, like how your screen will display, how your content will look like with some XML file, right? This also contain your simple configuration, and this will also display you the UI, how your UI will looks like again, right? These are the main three components for all the Android applications: manifest, your Java program, and your resources. After this part, now let's move toward our Android application components. We have already covered that part. After Android application components, now let's move toward the build process. How your application is gonna build, right? So if you remember this thing, like here in the main activity.java part, we have our Java program, right? When I simply click on build here and make this project, to simply compile my Java code. Let me just write down this thing here. So you should start with your Java code, right? You simply write your Java code. That Java code will be converted, will be simply compiled into your bytecode. And that specific bytecode is effectively, that specific bytecode can effectively executed on your normal powered system. That bytecode can work on your normal powered system, but it will not work for your low powered, low CPU powered systems, right? Because of that part, we need to convert, we need to translate. Here we have our translation part. Your bytecode will be translated into specifically designed. We call it DEX code, or we also call it DEX bytecode. So you can call it DEX code, you can call it DEX bytecode again. There was simple translation for the bytecode into Dalvik executable bytecode. Your DEX stands for Dalvik executable bytecode. You simply translate it with the help of some encoders, right? You simply translate this specific bytecode into our DEX code. And if you want to analyze this text code, we can also analyze this DEX code, and we call it Smiley code as well. That DEX code is also known as Smiley code, right? But again, that was the bytecode specifically for your devices. After generating your bytecode, right? This was just a Java. This is just a Java part. But again, for the application, we have different other components as well. Like we have our manifest file, we have our resources, and all your applications should be signed with a particular valid certificate, right? So all these resources, the configuration file, your Java program, and your certificates will be stored in an archive, and that specific archive is known as your APK. That specific archive is known as APK. We call it application package. Simple. That specific archive is known as application package, right? So again, it starts with your Java code. You simply add your Java code, and that Java code will be compiled into your bytecode, and that specific bytecode will be translated with some encoders into your text bytecode. Again, we call it Smiley code as well, right? And that specifically text bytecode can be stored into archive with some configuration file, with some resources, with some other certificates and other different options as well into archive, and that archive is known as APK, application package, right? If you simply unzip, if you simply extract that archive, you will see a list of all these things. If I simply go back to my Mobexler and let's just build that application, let's go with the other application as well. I have other I have other applications as well in my folders. So let's go with documents. Here we have different other applications. Like one of them was uh, insecure bank. Let's go with LL. Yes, we have these two applications. Let's say Diva Beta is again one of them. This browser agent is one of them. Also, this folder, like if I go with the status, go with IM status. This folder also contain a APK file. Right? If you simply extract that application with like unzip command, right, and go with base.apk, this will give you the complete content for this specific application. Right? Replace lib, yes, no, all. Let's go with all. And here we go. If I again list out all the components, we got some different files. Like we got some asset folder, we got some configuration file, we got some Java folders, we got some databases. Again, we got the DEX file. There was a translated dilute executable bytecode, right? Because the Java code will be compiled into bytecode, and your bytecode will be translated into DEX code. Right? For that part, we got our DEX files. That bytecode has an extension, we call it dot classes. That bytecode has an extension, we call it dot classes. Like let's say if you have a program, the file name would, let's say your project name would, let's say like ABCD. The project name was ABCD, right? Then that compiled bytecode will be named as ABCD dot classes. Simple. And if you translate that bytecode into DEX code, that will be named as ABCD dot DEX, right? That was your simple dilute executable code. Now you can execute this bytecode on your virtual machine or your Android virtual machine. Simple. That was your dilute executable machine, your DVM we call it, right? So your virtual machine, your dilute virtual machine can only work with the specific DEX files. Simple. And that DEX file, that particular application also contain a file. We call it, let me just check, we have this file here or not. Okay, we don't have file here maybe, but all your application consists of a file. We call it signature file. If I simply open this application on my Android Studio, maybe we got the file. Or let's open this application. Let's debug application here. I'm going with simple IAM status, and this was my base of APK, right? Let's open this file here, create new folder, and let's disassemble our classes.txt file. When you simply extract the application with your Android Studio, this will again give you the Smiley code. This will give you the Smiley code. This will not give you the Java code here. This will only give you the Smiley code, right? And again, I'm waiting for the like go. We have a different signature file out there. I forgot the application name, but application was used. to analyze the specific signature there. But again, all your software, all your particular applications for the mobile devices consist of some specific signatures. For they consist of unique signature, right? Or from their developer, from their developing company, you can say, right? So all your application consists of these three files at least. First one was your manifest, then we have Java, and then we have some external, which also consists of some values for the resources part as well. When you extract the application, this will also give you the libraries here, which were used by your system. You also got the list for your specific libraries here, right? If I simply extract this one with my CMD, we got the list here. Where is the CMD? Yeah, we got the list of different resources, different organization, and other different folders as libraries we have here. Kotlin we have here, like the databases we have here, simple text files we have, simple APK file we have, and other then this some properties as well, right? But again, you can easily extract that archive with simple unzip command. It's that easy, right? Or you can use some other softwares as well. We will cover up that part in our next classes, right? So after this simple build process, again, that archive consists of different files like simple text file, which is again the dynamic executable bytecode, consists of your configuration file, manifest file, your asset folder, your resources, your all the required libraries, and your digital certificate as well, right? When you first execute the specific build application, let's say you build the application, like if I go back to my mobile slow, yes. When I simply build that application for this test one, right? That application will be installed on my particular Android device here. When you execute that particular application for the first time, when you execute that particular application for the first time, your text code will be converted, will be translated into ODEX. That was your optimized dynamic executable bytecode. Right? And that ODEX file can only work on your device. That ODEX file is device specific. You cannot execute that ODEX file on other devices, but you can execute simple DEX files. You can execute DEX files on any device, but if that file is optimized by your device, right, that optimized files can only work on that specific device. Otherwise, you cannot execute that ODEX file on other devices. Simple, right? After first execution, your DEX file will be translated into ODEX. That was optimized DEX code, right? So that your device can start that application much fast as you can. For that part, we translate our DEX file into ODEX. Now, after this part, we have our simple permissions for the Android devices. So all the permissions, let's say, if I simply go with my camera back, like if you remember, when I open my camera, that asks me for different permission like access to camera. When you simply open any application, that application will simply ask you for different permission. Right? It means we have different permission groups in our Android device. If I simply go to my mobile store, let me close all these Android Studio windows here, close this one as well, and let's go back with our terminal. Now, all your Android devices, if I go with AddDB connect again to connect our devices, now go with ADB shell, right? So, in all your Android devices, we have a specific list of permissions. Again, it depends on your Android version. A permission list depends on your Android version. If I simply go with Android version 6, this consists around like 250 permissions, right? If I go with a much higher version, like simply if I go with Android version 10, this consists of around like 650, more than 650 permissions, right? And all these permissions were categorized in different groups. And those groups were generally known as simple your dangerous group or your unknown group, right? If I simply execute the command like pm hyphen list and then just go with different permissions, like if I simply go with the permission list, okay, permissions, all right, I'm missing something, Let's go back and let's go with ADB shell PM your list, and let's go with permissions. Right? If you simply display this list, you will got these much permissions out there, and you can use them in your particular application. Right? These were the permissions for your specifically Android version 6. So I simply store all these permissions on a simple text file. Just go with gedit and let's paste all these permissions. And if I go to the end, we have around like 394 permission in my Android version 6, right? But if again you execute the command for like Android version 10, you will got much more permissions. The permission list will simply increase, right? So we have more permissions in our latest Android versions like simple 10, 11, 7, 8, 9, right? Permissions were heavily increased in your Android version 7 mainly, right? If I execute the same command for different device, let's say I need to go with ADB disconnect and just go with IP address as 7 that we disconnected. Let's connect with our new Android device with version 10. Let's connect this one. Where is our settings? For Android version 10, you can directly open it this settings from your networks. Just open your Wi-Fi, and here we have our IP address as 1.16. Okay, let's connect. ADB connect your 192.168.1.16. Right? That's connected. Let's go with ADB shell again PM and list. Right? If you simply copy and paste them on your terminal on your simple text editor, this list will go to 650 plus permissions. Right? Again, it depends on your Android version, how many permissions you have, how much permissions you can access. And again, one more thing, all these permissions were categorized in some specific groups. These permissions were categorized in some groups, right? If you want to analyze this permission in specific groups at the time, you can just go with one more command out there. Let me just clean all these things and paste. Now, if I go at the end, you can see we have around like 678 permission in our Android version 10, but we don't have to allow for all these permissions because we have specific groups. So I simply go with groups out there. Let's go with permission hyphen groups, and I'm going with hyphen D. So my dangerous permissions only. Otherwise, you can simply go without D as well. And we got all these groups. We got all these groups in our Android permission part, right? These were the groups for my Android version 10. Like we have a group for our contact. My application will only ask me to access the contact, but it can perform different operation. Like we have different permission to access the contact. If I simply go with search and search here for contact, right? We can perform different actions on contact. Like you can read, you can write, you can modify different contact. We have other different actions as well on our contact. To simply display all the permission for these groups, just go with the command like permissions hyphen G and going with hyphen D as well, so that we can display permission for these groups much easily. Just press enter, and now you can verify this. All right. For the specific version 10, we don't have this permission listed here. Just go back here. I'm going with ADB disconnect again. Let's go with 1.16 and let's connect our new device. ADB connect 1.7 and execute the same command. Sorry, where is our connect? ADB 7 connected. Now let's execute the same command to list out all the permissions. And here you can see, like we can perform different actions on calendar. We can perform different actions through our phone. But my application, my Android device will only prompt me once, right? And when you allow the permission, that specific application will be added in the permission group for the specific phone permission. That permission will be that specific applications will be added in the particular group phone for this phone permission part, right? Then then your application can read your call logs, can call through your phone calls, can do whatever he wants, right? So all these actions can also be performed through your application. But your application or your Android device will only ask you once, right? When you allow the permission, that application will be added in this specific group, and after getting access to the specific group, your application can perform all these actions, right? Yes, same groups for different information, like you can perform different actions for your contacts, different phones we have, different calendars we have, but not all of the permissions were listed here. You can perform different actions on SMS as well, right? If I simply remove this -d and then press enter, we got some unlisted permissions as well. Not all these permissions were grouped here. We have some ungrouped permissions as well, right? Your device will ask you for all these permissions one by one. But generally, this kind of ungrouped permissions were allowed to your application when you install it. When you install your application, these kind of ungrouped permissions were allowed to your particular application. Your application don't have to ask you all the time. Your application will only ask you for these dangerous permissions like this one. And these permissions were generally asked to the user while runtime. Simple. Right? So you can also create an application for this kind of permission. All you have to do is just create an application for this kind of permissions, and after getting permission, you can perform any action without further notice to the user. Whenever you want, you can read the context. Whenever you want, you can just perform the calls logs part. You can perform the calls. You can make the calls. Whenever you want, you can access the camera. Whenever you want, you can access the location without further notification, without further notice to the user. Right? You can easily do this thing. All you need is access to the permission group. Right? So these were your major permissions in your Android devices. Right? The most important and the most critical thing in all your Android application is your permissions. Anyone can easily compromise your mobile device, compromise your Android device if you allow the permissions to your application, right? So just if your application want this permission for once, just allow the permission and just take the permission just after the specific action. Let's say my application wants to read the location for once, right? Just allow the location and after that just get the permission back. Simple. Right? So don't allow all the application, all the permission. Don't allow them. Right? Don't give the permissions. Permission are the most important part in your Android application, and your device can be easily compromised to these permissions. Right? After these simple permissions, we have our Android file structure. We have different files in our Android device. If you again go back to your mobile Explorer, you can go with the ADB shell, and you can go with LL. Okay, go with ls-l, and you can see we have different folders we have here. Right? Some of these folders were similar to your Linux part. If I simply open this one here, and if I simply go with gd // and if I go with ll here, some of the folders in this tab and here are somewhat similar. Like mnt was common, your dev was common, your act cache config. Some of the folders were common here, right? But most of these folders like bin, like your boot, your dev, your etc, these kind of common folders were also stored in your particular system directory. Most of the Linux folders like these one were stored in your system directory. If you go with cd system, and if you just go with ls-l here, you can see we have some common folder like loss plus found was there, framework was there, etc was there, bin was there, app was there, right? These were the simple common folder for your Linux part. But again, we have some other common folders as well which can be used for different things. And the most common folder out of all these was your data folder. This was the most common and most important folder. in your Android device, because this folder contains all your user data. All your applications, all your application data will be stored in this particular data folder. This is the most important folder out of all. Right? After this, you can move with the simple system folder. That was again an important part. All your simple external storage will be mounted, will be shown you to this specific SD card. Right? And that specific SD card was available in this specific storage folder. If you go to the storage cd // storage, that SD card folder was here inside this storage folder. Right? So all your external storage will be mounted in the MNT folder, and that will be listed here in the specific storage folder. Some of these were links. Some of these were links like this one, like this one. They were just links. They were just files, right? Again, that was a link. That was the directory. Sbin was a directory. Root was a directory. Simple, right? But not all of these were the directories. Like OEM, this particular folder contains some specific configurations, some specific logs from your manufacturer. Like all your OEM, like with OEM, which generally stands for original equipment manufacturer. Like if you have a mobile device from the Samsung, then Samsung was your OEM. The actual manufacturer for the electronic device is known as OEM, original equipment manufacturer. Simple, right? So OEM, this particular folder consists of different logs, different configuration file from your simple uh, manufacturer. Like simple logo you got at the beginning while you boot your device, you got some logo from the Samsung. All these kind of things, all these kind of logs from the manufacturers were stored in this particular OEM folder. This particular proc folder was used to store different process data, different process and the configuration file, and their data will be stored in this proc folder, right? MNT folder was used to store the mounted data. We go back to the MNT folder, or you can again that again stores your different mounted data here, right? These were again some configuration file for different processes out there. Like we have some init, we have some zygote, and another we have some other configuration files as well. But they were just simple common files for your Android devices. That etc is again a link. That dev contain different file. Like if I go back to cd .dev, okay, ls-l we need to perform, and this file contain your different services. This one will contain your different services and different configuration for your different services. That all the background processes and their configuration file will be stored in this particular dev folder. Right? Other than this dev, let me just go back and perform ls-l. We have some other folders as well, like we have a configuration folder, we have a cache folder, we have the ACC folder again. But the most important out of all these is your system, right? And your data. Where is the data? Yes. All your application or your installed application will be stored in the data folder. Inside the data folder, we have again different other folders as like user was there, simple your lost plus found was there, simple media was there, simple miscellaneous, backup, apps, and one more data folder was also there. Right? If you go back to the data folder, cd data, oops, this particular data folder, inside data folder, that consists of different files for your different applications. All these values are your users for different applications. Like I have application installed as test1, right? The specific username for the specific application test1, that username is u0_a52. Whenever you install application, your Android device will create a new user for your application, and that application name will be displayed here. Or if you want, you can also go with some other commands as well. Like if you simply perform ps, this ps command can also give you a list of different processes and their usernames here, right? If you want, you can easily identify these things. Right? So they were just usernames here. Other than this, if you go back to the cd // I'm going with the app folder here and going with ls-l. All your installed applications, like which applications you have installed, not the system application, not system application. All the application, all the softwares you have installed in your Android device will be displayed here in this particular app folder, right? All these folders, all these application data will be stored in this particular app folder here. If I go with any CD, let's go with like jacker.asim.dy. If I go with lsip, again, this again consists of different files. One of them was base.apk. Whenever you install a folder, whenever you install the application, whenever you install application, your system will again store the base APK file in this particular folder, this particular folder with the application package name, right? And other libraries and other MNT, OBB, and other different folders will also be stored in this particular package folder, in this particular data/app folder, right? Again, most important thing is your data folder is important, right? All your user data is stored in this particular data folder, and when you flush, when you simply go in factory reset part, when you simply factory reset your device, at that time only this specific data folder is erased. When you clean your device, when you reset your device for the factory reset, only this data folder was cleared, only this data folder is erased, right? Because all the user data is stored in this particular data folder for different applications, for different system application, as well as different user applications here, right? So, so the basic introduction for your Android devices. From the next session, we will start with our practicals part, and before that, we will go with simple basic ADB commands, and then we go with simple our first Diva Beta application, right? That's all from my side. If you guys have any question, have any doubts, then you can ask me.